Okay, we'll finish up this section with a theorem and one final example. The theorem is called the side-splitting theorem, and it's going to be very similar to something we did in the previous video called the ratio parallel theorem. Given triangle ABC, suppose a line L is parallel to BC. Okay, don't draw it just yet. Okay, if L, that line, intersects AB, the line segment at the point E, so you can't draw the parallel line down here, we have to draw it up here. So maybe I'll put, that's the point E, and then I'll put the line parallel to BC. It's going to look like this. Okay, and this is my line L. And so L intersected with AB, it intersects at the point E, and L intersected with AC. AC intersected with that is going to be this point right here, and we're going to call that F. Then, very similar to that previous theorem, the ratio, the fraction, this distance, AE, over the whole distance AB, which is roughly speaking 3/4, I think. From A, down to E, I'm about 3/4 of the way to the point B. That ratio is equal to AF, that length, over AC. We knew that from the previous theorem. And there's one more ratio that's true. AE divided by BE is equal to what you might expect on the other side. AF divided by CF. Okay, so just some more ratios that work. Remember, it requires that the line going through this triangle be parallel to one of the sides. In this case, it was parallel to the side BC. All right, for our last example, we're just going to have to find out what a bunch of variables are in this diagram. We have some of the values given, and then we have an x and a y, x, y, z, w, u, and so on. So we're going to have to find all of those. So in this diagram, the parallel lines, which are these dashed lines, are equally spaced. That's very helpful. Okay. And the length distance from A to E, so from there to there, is 24. All right, and from A prime to E prime, from there to there, is 32. Given all that, we need to find all of these variables, x, y, z, w, u. And we're just going to use the trapezoid median theorem over and over again. And the big hint is find z first. Well, why is that? Well, if that's x, then this is also x, and this is x, and this is x, because they are equally spaced. If this is u, then this is u, then this is u, and that's u as well. But notice what we have. Notice the trapezoid A prime, E prime, E. What do we know about the line segment C, C prime? It is the median of the trapezoid. Okay? It's the median of the trapezoid. So what is z equal to? Z is going to be 1/2 of the sum 12 and 34. Okay, let's see what that is. Because this is, the top one is 12, the bottom one's 34. The median is going to have the average of those two. So that is 1/2 times 34, 46. That's 23. So z is 23. We're going to repeat that process 2 more times to get y and w. Why? Well, here we have a trapezoid, A, A prime, C prime, C. And B is the median. I'm sorry, B, B prime is the median. And it has length y. Y is going to be 1/2 the sum of 12 and 23. So go over here. Y equals 1/2 of the sum of 12 and 23. So that's 1/2 of 23, 33, 35, which is 17.5, 17.5. That was 23, I messed it up there. Okay, now we'll find W. W is, if we consider this trapezoid, C, C, C prime, E prime, E, W is the length of the median, D, D prime. So W is going to be 1/2 of 23 plus 34. That's 1/2 of 34, 44, 54, 57, which is 28.5, or 28.5. Okay, so now what do we get for, we know that's 24, and that's equally spaced. These are equally spaced, so 1, 2, 3, 4. If this whole thing is 24, then this has to be 24 divided by 4, so x is equal to 6. And this one is simply length 32, and they're equally spaced, so we have 1, 2, 3, 4. So 32 divided by 4, u is 8. That's an 8, that's an 8, and that's an 8. So we figured out what x, w, or x, y, z, w, and u were, and that was what was asked for.